All right, good morning and welcome back to Elements for Calculus. So here we are with continuing our discussion on U substitution here. So we have I have events. I don't. Okay. So what we're going to have here is, there we go. Now I have a mouse. Okay. So what we're going to be talking about is U substitution. U substitution is effectively doing the chain rule in reverse. Okay. So let's see here. So we're going to do U substitution, which is effectively chain rule backwards. Okay. I know everybody remembers chain rule from Calculus 1 because that's everybody's favorite part. Okay. So we'll just do a couple of examples here and I'll walk you through what's going on here. So we have integral of, okay, we have 3x squared, okay, minus 5, all raised to the fourth power, times 2x dx. All right. Now, before you use substitution, what we'd have to do is we'd have to FOIL this thing out, right, to the fourth power, okay, and then multiply term by 2x and integrate this whole thing multiplied out times the 2x, integrate that piece by piece. Now, as fun as that sounds, and I'm sure everybody would love to do that problem, we don't have that much time on this planet, so we're not going to do that. So what we're going to do is we're going to make a little substitution here. We're going to say, hey, we could say let u equal 3x squared minus 5. Okay. You know what we're going to say is every time you make a substitution in calculus, almost your next step, okay, should be du equals, okay, and take the derivative of that substitution. Okay, 3 times 2 is going to be 6. We end up with 6x. 5 is a constant, and it really should be as reflexive as something like, right? And you should put the last little two bits in there, okay, in order to finish that off. So it really should be like that much of a reflexive response for you. Okay, if you're going to make a substitution, your next step is going to be. And this is something that I really like to see out of my students when I would teach this class, to say let u equal and declare your u, like we're going to let u equal, and then du right underneath of it. And it really helps follow along with your work. Because while you're in the thick of it, you're doing all of this calculus, you're really good at it, you're getting all this practice. Okay, I got news for you. I used to work as an engineer, and the lady I worked for, she's very, very competent, very, very bright. Um, but most of the stuff that I had done in grad school, she hadn't done it in at least 20 years, and probably closer to 40 or 50 because she was close to retirement. So if I skip a lot of steps with my presentation, she's like, "Wait a minute, like you're not showing off here. You're pretty much just confusing me. You're talking too fast, and you're like acting like a used car salesman here. So please slow down and like explain your steps so we can follow what's going along because not everybody's going to have your expertise. So you're writing to the person who may not know exactly what you know. So it's always a good habit. It's like if you're going to make a U substitution, declare your U, say your DU. Okay. And then, oh, forgot, put our dx in here because we have to do chain rule for the x. We have a derivative of x, which is going to be our dx. Now what we're going to do is we're going to solve for dx. Okay, so we could say dx equals, okay, and then all we're going to do is say, well, this is going to be 1 over 6x times du. Okay, all I'm doing is dividing both sides by 6x here. So du equals, right, and then solve for dx. So when I go to plug this back into my equation here, right, we're going to have integral of Well, what the heck is this piece in the middle here? This is just u, right? Because our u is going to be 3x squared minus 5. So that's u to the fourth. And then what do we have over here? We have 2x, right? This is from the original problems. We still have a 2x here. There we go, 2x times our dx. Now, what the heck is dx? dx is 1 over 6x times du. There's some stuff that's going to cancel here, okay? The 2 and the 6 are going to cancel, so we're effectively left with 1/3, the integral of 1/3 u to the fourth. And the only thing that is left in this brackets here is going to be our du. Now, constants will float through the integral sign, just like constants will float through a derivative. Okay, so we're going to end up with 1/3 integral u to the fourth du. Now we can integrate this using our power rule. That's not going to be so bad. Right, so we're going to end up with 1/3 u to the fifth plus arbitrary constant. Okay, it's a joke I saw the other day. It's like if you're taking a multiple choice calculus test, always pick C, because they can't say you forgot the C. All right, so that's always a good thing. So let's go back and resubstitute. So we have 1/3. What was u? My u was equal to 3x squared plus 5, 3x squared minus 5 rather. So we have 3x squared minus 5. What was the power on this? Raised to the fifth power plus c. And that's the kind of answer that we'd be looking for. Okay, we'll go ahead and box that, say well done. Okay, so some of the things, some of the pitfalls that we have here, okay, is one of the things that I always get to deal with my students is like, please declare your u so I could follow what's going on. Okay. Right now, I'm very lucky. I had a stroke last year, so sometimes that's why I can't see quite as well as I'd like to. So you have to kind of leave me a trail of breadcrumbs so that I could follow it. But later on in your career, if you're going to be doing this, chances are you're the expert in the room. So leave a trail of breadcrumbs so that the person who had Calc 2 like 30 years ago could say, oh, I remember how to do that. That was quite clever, the way you made that substitution. Like, let them think that. So you can show what your u is and show what your du is. Okay. And then we go ahead and finish our integration here. Okay, so that's what we're going to do. The other issue that I always see with students is that they get to this spot here, and sometimes they don't make a good u substitution. And by the way, this is a trial and error process. So some u's you're going to come out and say, well, that was obvious. Some you won't. Okay, it's going to take a while to always get the right u. Okay, you won't always get the right u. Okay, it's just a thing. You're going to have to get used to the fact that you're going to make this mistake, and that's okay. That's why we do it on paper and pencil. We can erase. Okay, we can scratch it out and try the next one. But what's going to happen here is these x's, all of these x's, that all has to cancel. Notice after I've made a substitution, there's no more x's in this problem. It's all in u's, okay? Or whatever letter you want to pick, it's all in that letter, okay? So there can't be any more x's. We can't mix and match variables in here. They have to be all the same variable. That's how you know you did it right. So if you're still left with an extra u, you're still left with an extra something in there, or an extra x in there, you know you picked the wrong u substitution, or you have to finagle it a little bit to make it work. Okay, and I'll show you guys a couple of those tomorrow. But I just wanted to get through like your basic u substitution kind of an idea here. Okay, so let's see here. Let's see if we can get to a couple more. Okay, there is a rule. Okay, we have integral of say e to the negative 3x. Now there is a rule that says, hey, if you have e to the kx, there's a rule you can memorize. Okay, and for you students, for these folks that are in anatomy and physiology, how much stuff you already got to memorize? Too much, right? If you're in chemistry, how much stuff do you have to keep memorized? Way too much. Okay, to this day, I still have Avogadro's numbers printed into my brain somewhere. It's at 6.02 3 times 10 to the 23rd power. So we know this because we drilled it into our brains over and over and over again. How much stuff you want to keep memorizing? Not so much. So I waited to do the rules for exponents until today because I use this as a use substitution rather than as a rule to memorize. So I'm going to say let u equal negative 3x, du equals negative 3 dx. Again, we're going to solve for dx here. Solve for dx. So what are we going to have? We're going to have du over negative 3 equals dx. So when I go back down here to do my integration, we're going to have integral of e to the, that's an integral sign. Okay, I'm sorry about that. E to the, we said u was the problematic part, so it's e to the u. And my dx, that's going to be du over negative 3. There's a times in between here. So since there's a times in between here, we could simplify this to say this is negative 1/3 integral e to the u du. This is the nicest, easiest integral you're ever going to get. Okay, so we're going to get negative 1/3. Integral of e to the u is e to the u plus c, of course. Okay, and this is equal to negative 1/3 e. What the heck was u again? Negative 3x plus c. Okay, and that's what we're going to have for our answer here. So you could memorize that formula. I'm not going to tell you that you're wrong to do that, but how much stuff you already memorizing for your other classes? I would not recommend, memorizing stuff for the sake of like, well, it's a formula, I should memorize it. Like, you can say that, but how many other formulas you have to know? How many muscles do you have to know? How many bones do you have to know? How much stuff do you already carry around in your head? So I try to minimize how much stuff I have to keep memorized. Okay, so let's do one more here. Actually, let's do 2 more, but let's do another one. It's a little bit harder. It looks a little bit harder. Okay. All right, so we have integral of, what am I doing here? There we go, sorry about that. So we have integral of, and I'm going to say this is going to be e to the 2x divided by e to the 2x plus 5 dx. Well, when you're looking at this, where's the problem part? The problem is whatever's on the bottom, right? Because if it was just e to the 2x, I could integrate that, no problem. But this thing on the bottom, that's a problem. So let's let u equal the thing that's a problem. So let u equal, okay, e to the 2x plus there, plus 5. When I take my du, right, we're going to have e to the 2x, don't forget the chain rule, times 2. Okay, the derivative of a 5 is just going to be 0. We have a dx here because of that chain rule. We're going to solve for dx. Okay, so dx is going to be, we have du over 2 e to the 2x. That equals dx. Okay, that's all I did is just divide by the e to the 2x and the 2 there. So when I go back to my original problem here, let's see if I can't do this. There we go. So we're going to have integral. All right. E to the 2x plus 5. Well, we're going to have our e to the 2x. I couldn't do anything with that just off the top of my head. On the bottom, e to the 2x plus 5. That's a u. Now my dx, right, that's du divided by 2 e to the 2x. So notice that the e to the 2x is canceled. That's the whole point of doing this. This is all times, so this is 2 that's out in front here. So this is a 1/2 times 1 over u, and then the du is on the top here. Okay, one of the things that I always tell my students when I teach this class is, I know that a lot of you have engineer friends, you have physics friends, and you're like, you're not the friend that's good at math because you're the biology major, you're the chemistry major, you are good at math, you passed Calc 1. There's not a lot of people that have done that. Okay, so a lot of the things that you're going to be doing later in your life, it's like, I'm sorry to break this to you, but you are now the friend who is good at math. Okay. So you're going to have to know like these little tricks. Like we could put this 1/2 out in front here like this. So this is going to be 1/2 integral. This is 1 over u du. Now, this is one of those special rules, right? We have a logarithm. So we're going to end up with 1 over u, or 1 over half rather, 1 over 2, times the integral of 1 over u is natural log of, I'll put absolute values of u plus c. Okay, now we go back, say we have to go back to x space. We're in u space right now. We're going to go back to x space. So this is going to be 1/2. This is ln. What the heck was u? U was e to the 2x plus 5. So here's the thing about e to the 2x plus 5. That function is always positive. So do I need the absolute values if this thing is always going to be positive? Yeah, it's always going to be positive. So we can get rid of the absolute value signs. Because like if I have like, hey, what's the absolute value of 10? It's 10. The absolute value of e to the 2x plus 5 is e to the 2x plus 5. So we can just replace that and then have our plus c in there. And that looks a little less intimidating than having absolute values in there. So there's our answer. That's what we're going to have for it. Okay, and that's a beautiful answer for us. Okay, so that's the kind of thing that I'd be looking for if I was grading, if I was teaching you guys this class. Okay, let's see. What if we do one that doesn't quite fit? So what if I do that? I do an integral of, and I take the square root of x squared minus 6x. So no example here. Okay, and then outside of the radical, I've got x minus 3 dx. Okay, so this one's a little tricky, not really, but a little bit tricky in the fact that if we say, well, what's our u going to be here? I'm going to say let u equal. Notice same kind of what's going on with this little piece here, but so we're going to say let u equal. We have x squared minus 6x. So one thing I'd like to do with this is I'd like to kind of put this in brackets and say we have x squared minus 6x raised to the 1/2 power, just because it makes it look like a calculus problem rather than an algebra problem. And then we have our x minus 3 dx. I'm not going to put the 1/2 in here, so I can take the derivative of that. Now we're going to have to deal with a whole chain rule thing, and that's going to be delightful. Okay, sometimes that's the right way to go, but in this case, I think, that's probably going to make things a little bit harder. Okay, and it's okay. If you guess the wrong u, and you're like, I kind of got myself into a knot here. That's going to happen. You should expect to guess a wrong u occasionally. Everybody does. Our du is equal to 2x minus 6. Now that looks suspiciously similar to x minus 3. So we're going to say, parentheses here, we have our dx. We're going to factor out a 2. That's 2x minus 3 dx. Okay, so the whole goal for this thing is you have to force this piece to kind of look like that piece. Okay, so think about Cinderella's stepsisters. They're going to shove their foot into that shoe whether it fits or not. So we might have to make a little bit of allowances to make sure that our foot fits into that shoe, but that's what we're going to do with this. Okay, and that's what we're happening right here. And again, solve for dx. Okay, so we have our, here's my pen here. Okay, so we're going to solve for dx. We have du equals, right? Or du equals this thing right here. So we don't want du equals, we want dx. That's what we're on the way to go with. Right, so we want, there it is. Okay, so here we have dx equals 1 over twice x minus 3, okay, du. That's where I pulled it right here. Okay, 1 over 2 minus 3 dx. Okay, that equals du there. Okay, so we have that. All I did was divide by this bit here. Now when I go back to back substitute here, okay, we're going to have integral of, okay, u to the 1/2 power, okay? And then what do we have left? We have x minus 3. Okay, we have our x minus 3. And then we have our dx, which is 1 over 2x minus 3 du. Okay, this is going to cancel here. So we're going to end up with this 1/2 is going to come out front. So we have 1 over 2 integral u to the 1/2 du. Okay. One of the other things about the du part is it has to be on the baseline of the problem. It can't be in the exponent, it can't be in the fraction, it can't be under a square root. If you end up with the du in some kind of a function, you've done something wrong. Okay, that's not the right u. You should pick a different u and restart the problem that way. Okay, something went wrong. So make sure your u is on the regular baseline, isn't inside of a radical, inside of a function, inside of a fraction, nothing like that. Okay, and then we go ahead and we integrate. So it's 1/2 plus 1, that's going to be 3/2. We are dividing by 3/2. Remember that reciprocal rule, so we're going to have 2/3 times 1/2 times u to the 3/2, and I forgot something, plus our arbitrary constant. The 2's cancel. Okay, so we're going to end up with, okay, we're going to end up with 1 over 3. What was u again? Okay, because the 2's cancel, so we have 1 over 3, and then u was, let's see here, let u equal x squared minus 6x. So we have x squared minus 6x, all raised to the 3/2 power. Don't worry about that. And then plus an arbitrary constant. And that's the kind of answer we're looking for. Okay, and I know that looks horrible and disgusting, but that's just the way, that's the nature of these kinds of problems. Okay, so I hope that helps a little bit. I've just got one more, and this one's a little bit of a trickier one. If I was teaching this class again, this is the kind of problem I would automatically put on there just because I know that it's a little intimidating. So I want to see if you did your homework. Okay, that's the point of this kind of a problem. Okay, so let's see here. So I have integral of, and now I have the square root of 2 plus ln x square root all over x dx. Okay, what's the scariest looking part of this thing? It's the thing inside of the square root, isn't it? So that's what we're going to deal with first. And we're going to say let u equal, where's my pen? I'm going to have to fix this little thing here. So we're going to say let u equal 2 plus ln x du. Okay, just like, right? We have to go through and do that. Du equals, okay, derivative of a constant is 0. The derivative of natural log of x is 1 over x dx. Solve for dx. Okay, so we have dx equals x du. Okay, so we have dx equals x times du. So let's start substituting. So we have integral of, can I say that this is going to be 2 plus natural log of x, that was our u to the 1/2 power. And then we have x, and then what was my dx? My dx was x times du. So those cancel, that's the whole point. Okay, so we have integral of u to the 1/2 power du. Notice there's no x's in here. If there was any x's in here, I'd have to reset, recalibrate, and choose a different u, right? Or possibly use a different integration technique, but right now you only have this one. So this is it. This is the only tool that you have. Okay, so everything, this is a nail, everything has to be the hammer. We're going to use that to break all of these problems. Okay, so go ahead and integrate. Okay, so we end up with u, where the heck is my pen here? There he is. So we have u to the 3/2. We have a 2/3 plus our constant, right? Don't let me forget. Don't you forget either. Okay. I have a colleague for if you forget your C, it's an automatic 1-point deduction. Okay, so if you have a 10-point integral quiz and you forget your C on every one of them, you might as well have not gotten out of bed this morning because it's automatically -10 because you forgot all of your C's. Okay. So we have 2/3. Where's our 2/3 here? So for that particular class, if you made a mistake, other mistakes, you could actually end up with a negative score on that quiz. I have yet to do that, but I had a chemistry teacher that would take off more points than a problem was worth if you thought you did something inappropriate. So my U was 2 plus ln x. What was the power on that? It's 3/2 plus, plus my arbitrary constant. And that's the kind of thing that we're looking to do. Okay, so I'm going to go ahead and stop our video there. And tomorrow we'll do one that's we'll do a couple of tricky ones. And I hope that helps for you. And I wish you the best of luck. Thank you.